All right, trigonometry, we start with an analysis of the unit circle. So as we begin trigonometry, it all has to do with something referred to as a squared plus b squared is equal to c squared. The Pythagorean theorem is really the basis for all trigonometry. And from that, we get the equation for circles, which is x squared plus y squared is equal to r squared. Hopefully those look familiar to you. But we talk about the unit circle, and the unit circle is very special because it has a radius of 1. So it's a circle with a radius of 1 that's centered at 0, 0. And it therefore satisfies the equation x squared plus y squared is equal to 1. Now, suppose that this drawing below is a picture of the unit circle, where this coordinate is 0, 0. If the radius is 1, that means each of these lengths are 1 unit, which would mean that this coordinate, where the x-axis intersects the unit circle, would be a coordinate of 1, 0. And this coordinate, as you try to think about what it would be, 0, 1. And this coordinate would be negative 1, 0. And this coordinate would be 0, negative 1. What we would like to do is confirm that there are other points on the unit circle other than just these 4. These 4 are very important. You're going to continue to use them for years to come. But the root of 3 over 2 and negative 1/2, that is a point on the unit circle. How can I check? You could take the root of 3 over 2 and square it and add it to negative 1/2 squared, and we will see if we come out with 1. The root of 3 squared is 3. 2 squared is 4. Negative 1 squared is 1, and 2 squared is 4. 3/4 plus 1/4 is 1. So therefore, it is on the unit circle. You end up dealing with a lot of fractions when it comes to the unit circle, so we need to get used to that. We're also going to look at example 2. It says that point P is a point that lies in the 3rd quadrant. Remember, we have 1st quadrant, 2nd quadrant, 3rd quadrant, and 4th quadrant. Sometimes assume people remember all that. And the x-coordinate is negative 2/5. So if the x-coordinate is negative 2 over 5, we want to determine the y-coordinate. Well, we will set up the formula for the unit circle, which is negative 2 over 5 squared plus y squared is 1. Negative 2 over 5 squared is 4 over 25. I'm going to change this 1 over here to 25 over 25. So y squared is equal to 21 over 25. So I square root both sides. Y is equal to plus or minus the root of 21 over 5. Now, do we choose the positive or the negative? Well, if you consider the point, it says it's in the 3rd quadrant. If I'm back 2/5 and then down a certain amount in the 3rd quadrant, that means that this value is negative and this value is negative. So therefore, point P is going to be negative 2/5 and negative root of 21 over 5. Now that you've seen how to use the unit circle, we need to talk about the type of angles that you were measuring. This starts at 0 degrees. The angle that is formed we call theta. Theta is Theta. It's a Greek letter for TH. We use it to reference angles. As we head around the circle, we cross 90 degrees, 180 degrees, 270 degrees, and back to 360 degrees. As you consider a degree, 1 degree would be 1/360th of the circle. So it would be just a sliver. So in this case, theta would be equal to 1 degree, or 1/360th of the circle. Now, the best way for me to explain to you about degree measure and radian measure is that degree measure is kind of like miles, and radian measure is kind of like kilometers. And the fact is that we like miles, but the fact is that kilometers makes a lot more sense to the rest of the world. And you might be very used to degrees, but in math, radians works a lot better. In fact, in calculus, I would say that 98% of the time we work with radians. Very rarely do we ever use degree measurement. So there's two ways to measure angles. You can measure them using degrees or using radians. A radian is bigger than a degree. 1 radian is significantly bigger than 1 degree. But how much bigger? Well, I'll help you discover that. The key word for radian is radius. So 1 radian is the angle formed when the radius is the same length as the arc length. So I'm going to construct a picture here and suggest that this green curve also has a length of r. When 1 radius wraps on the arc so that these are all r, that is then 1 radian. So if you construct a second one and a third one, you can see that there's a little bit more than 3 by the time you get to 180 degrees. And if you construct another one and another one and another one, you can see there's a little bit more than 4, 5, and 6. You can see there's a little bit more than 6 that fit in 360 degrees. So that makes people uncomfortable because it's not an integer number that fits in 180 degrees nor in 360 degrees. So it's a number just a little bit more than 3, or 3.14. Yes, it is true that pi radians is the same as 180 degrees. And 0 degrees is 0 radians, and 360 degrees is going to be 2 pi radians, or 6.28. So those are synonymous with each other. And that will help us to start to build some important things on the unit circle. First, let us decide how to convert between degrees and radians. Degrees to radians. You take the angle measure, you multiply it by pi, and you divide it by theta. And that's how you go, theta multiplied by pi and divided by 180. That's how you convert degrees to radians. In order to convert radians to degrees, we take theta and we multiply it by 180 and we divide it by pi. So let's start to build some of these important elements here. This is pi, or 180 degrees. This is 0, or 0 degrees. It is also 360 degrees, which is 2 pi radians. So let's begin to mark off some of these other measurements. First of all, I know that this is 90 degrees. And 90 is half of 180. So it would be pi over 2. If I divide 90 in half, I get 45. And so that would be pi over 4. Let's consider 60 degrees. 60 is 1/3 of 180. So therefore it's pi over 3. And 30 degrees, 30 is 1/6 of 180. So it's pi over 6. I'll write this out for you so you can see exactly what's happening. You would take 30 degrees and convert it to radians. You take 30 times pi divided by 180. 30 over 180 becomes pi over 6. Very simple. We'll take 90. 90 times pi divided by 180. Pi over 2. We will take 60 times pi over 180. Notice 60 goes into 180 3 times, pi over 3. So that conversion works out quite nicely. I'm going to build some other values around here. Let's say 120, 135, 200, or I'm sorry, 150, 210, 225, 240, 270, 300, 315, 330. So I would like to convert 120 into radians. You can take 120 times pi divided by 180. That will work every single time. Notice you can cross off the zeros. We get 12 pi over 180. Both are divisible by, or 12 pi over 18. Both are divisible by 6, so you get 2 pi over 3. There's an easier way to do it, folks. Simply look at these. Which degree measure divides evenly into 120? Well, you would say 60, and you would say 30. But which is larger? 60. How many times does 60 go into 120? Twice. So it's 2 pi over 3. Instead of 1 pi over 3, it's 2 pi over 3. Look at 150. What divides evenly into 150? 30 does. How many times does 30 go into 150? 5 times. So it's 5 of the pi over 6s. 135 will get tricky here. Obviously, it ends in a 5, so therefore it will be 45. 45 goes in once to give you 45, twice to give you 90, and 3 times to give you 135. You can see it takes 3 marks to get there, so it's 3 pi over 4. If you continue to work your way around, 210 is divisible by 30. 7 times, so 7 pi over 6. 240 is divisible by 60. Goes in 4 times, so 4 pi over 3. 270 is divisible by 90. 3 times, so 3 pi over 2. 225, well, it's going to be a 45. We had 1 of the 45s, 2 of the 45s, 3, 4, and 5. 5 of the 45, so 5 pi over 4. 300 is divisible by 60. 5 times, so 5 pi over 3. 315, that's going to be another 45. There's 7 of them, 7 pi over 4. And 330 is divisible by 30, 11 times, so 11 pi over 6. So we should be able to make these pretty easily, okay? Now, notice what we've done here. It says rewrite each angle in radian measure as a multiple of pi. We've done that for 0 and 30, but suppose we have a different one, like 105. You had 105 pi, and you would divide it by 180. There, it's not a nice value. You actually need to figure out what 105 and 180 are both divisible by. Seems like they would both be divisible by 5. 105 divided by 5, and we get 21. And 180 divided by 5 is 36. Looks like those are both divisible by 3. We get 7 pi over 12. We already did 240. That was 4 pi over 3. We already did 90. You can also have negative angles like negative 135. That would be negative 3 pi over 4. Let's try something like 450. 450 pi over 180. If I could cross off the zeros, I like to cross off the zeros. 45 and 18 are divisible by 3. I have 15 pi over 6. Both are divisible by 3, so I like to divide by 3, and I get 5 pi over 2. 5 pi over 2. Negative 300, we know that positive 300 is, in fact, 5 pi over 3. Since it's negative, it would be negative 5 pi over 3. Let's turn to your worksheet so that we can understand the tasks that you're going to be asked to perform. There's going to be 3 of them. Number 1, convert from degrees to radians. So when you see this, you'll take 140 times pi divided by 180. Notice the zeros cancel. And then 14 over 18 reduces to 7 pi over 9. The second part you're going to be asked to do is to convert from radians to degrees. We take 3 pi over 5 and we multiply by 180 over pi. Notice the pi's cancel. 180 divided by 5 is 36. And 36 times 3 is 108. You can go ahead and use your calculator there. So those are your 2 skills. And now for your 3rd skill, you will be able to sketch angles in standard position. What it means to sketch an angle in standard position is this. You always start here. 300 degrees, let's see, that'll be 90. That'll be 180. That'll be 270. And then 360. So 300 would place you about right there. And what we do is we draw the arc like that to show that that's how we rotated. That's the angle measure that we're talking about. Whereas you notice for negative 120, there you're going in the opposite direction. So this would be negative 90. I need to go 30 more to get to negative 120. So make sure you draw your little arc there. And the next one, you can see that it's 500. That means that you go more than once around. Well, if you go more than once around, you can see that you get to 360, and then you have to go 140 more, which would place you about right there. So that's how you show your angle measurements. So be ready to do that for radians. If you need to convert them back to degrees, go ahead or work through that and try those out. Okay, folks, good luck. Can't wait to see you in class soon.